Hello and welcome. Today we're going to be looking at question number 6 on the 2011 Form A of the AP Chemistry exam. As always, we're going to be looking through this entire question so that you understand how to look at these questions. If you like these videos or find them informative, please be sure to like and subscribe. With that, let's get started on our question. Alright, so part A, we're told that in an experiment, all the air in a rigid 2.0 liter flask is pumped out. Then some liquid ethanol is injected into the second flask, which is held at 35 degrees Celsius. The amount of liquid ethanol initially decreases, but after 5 minutes, the amount of liquid ethanol in the flask remains constant. Ethanol has a boiling point of 78.5 degrees Celsius and an equilibrium vapor pressure of 100 torr at 35 degrees Celsius. So then, we're asked when the amount of liquid ethanol in the flask is constant, is the pressure in the flask greater than, less than, or equal to 100 torr? And we're asked to justify our answer. Well, let's think about this. So since the amount of liquid is not changing in the system is at equilibrium, right? The rates going in both directions are the same, so nothing is changing, it's at equilibrium. Right, so that means that the amount of gas is also not changing, so the pressure stays constant at 100 torr. Right, so since the amount of gas is not changing, the number of moles is the same, the pressure is the same, and the pressure stays at 100 torr. Let's keep going. Alright, part B, the flask is then heated to 45 degrees Celsius and the pressure in the flask increases. In terms of kinetic molecular theory, provide two reasons that the pressure in the flask is greater at 45 degrees Celsius than 35 degrees Celsius. So since the temperature has increased, the average kinetic energy has increased, the molecules are moving at an increased velocity. They will collide with the walls of the container more often, increasing the pressure. They also collide with more force into the container walls due to the increased velocity. Right, there are physics reasons behind both of these, but you don't really need to actually understand the physics behind it. You just need to remember that when it's going faster, it's going to collide more, it's going to collide harder, both of which increases the pressure on a surface, on an object. Let's keep going. Alright, so for part C, we're told that in a second experiment, which is performed at a much higher temperature, a sample of ethanol gas and a copper catalyst are placed in a rigid empty flask at 1.0 liters. The temperature of the flask is held constant, and the initial concentration of the ethanol gas is 0.01 molar. The ethanol begins to decompose according to the chemical reaction represented below. And we're given that ethanol goes to two other gases. And the concentration of ethanol gas over time is used to create the three graphs below. So let's see what we can do about this. What can we do about this question? Well, we know that whichever one is the correct graph is going to be linear. It's going to be straight. And only the first graph, the ethanol versus time. Ethanol versus time is what? That is 0th order. So 0th order, and then since the graph of ethanol versus time is linear. Let's keep going. And we're asked for the rate law of the reaction. Well, our only reactant here is ethanol, which is 0th order, so our rate is just equal to K. That's our rate. And then part 3, we're trying to find the rate constant for the reaction, including units. So all we got to do is we just have to find the negative, we just have to find the rate, which is the negative of the slope, right? So we look at the graph ethanol versus time, and we get 0.002 minus 0.01 over 2000 minus 0, which is going to end up being 4 times 10 to the negative 6 meters per, not molarity per second, not meters per second, that's physics. Molarity per second is our rate. And the reason we have those units is because the rate is in molarity per unit. So we need to align with that rate since it's just rate equals K. Let's move on to our last part. Pressure in the flask at the beginning of the experiment is 0.40 atmospheres. If the ethanol completely decomposes, what is the final pressure in the flask? Well, let's think about this. So we started at 1 mole of gas, say, for each mole of gas, we ended up with 2 moles of gas. So it essentially just doubled the number of moles of gas, and the temperature stayed the same, the volume stayed the same, the rate constant is a constant, so it doesn't change. So the pressure is also going to double. The pressure doubles from the 0.4 atm to 0.8 atm, 0.80 atm. And that is going to be our final pressure. And that is going to be the answer to part D. And that is it for this question. I know it's significantly shorter than the other questions we've done. That's just how these questions are. And I will see you next time when we continue looking at more AP Chemistry FRQs. See you later.